Recording was weird earlier today. Let's hope it's working well now. Solving equations. So we're just going to jump right to a challenging equation here. And the equation is A equals a fancy fraction, V minus V with a subscript 0 over T minus T with a subscript 0. And my hope is that looks kind of familiar to you because that is very much like our slope equation, m equals y subscript, usually we have a 2 there, minus y subscript 1 over x subscript 2 minus x subscript 1. So this is just a version of that. This one has a special meaning. The v's in the top are velocities or speeds. Speed. And the guys in the bottom, well, they're just times. And often in physics, we use meters in seconds, sometimes feet per second when we're talking about velocities and speeds, and sometimes we need miles per hour. So it could be these velocities up here are going to be measured in feet per second. And the times in the bottom are going to be measured in seconds. And when I take velocity over time, that is a change in speed is what I'm calculating here. So change in speed. And does anybody know another word for change in speed that starts with an A? Change in speed. You're driving your car and you step on the pedal and your speed increases on one pedal and decreases on the other, and that is called what? No takers? Come on. Someone's got this. What happens when you step on the gas in a car? You speed up or?
Acceleration.
Acceleration! Woo! Yeah, that's what the A is for. So this is an acceleration formula. It's called average acceleration because I just have two velocities in two times. So this is a formula for average acceleration. Let's use green again. Formula for average. There we go. Acceleration. We're just going to play with this formula a little bit. So if we know an acceleration and a starting speed and some times, we can solve for, say, this velocity there. So I'm just going to tell you what each of these means. So the A is average acceleration. That's my A. My V all by itself is the final speed, aka velocity. The V with the subscript 0, that would be the initial or starting speed. And each of those speeds happens at a particular time. So we have T by itself as the final time, and T with the subscript 0 is the initial time. And often the initial time is 0 itself, but sometimes it's not. It just kind of depends on the situation. Other things about this, we're going to use in the problems, is going to come up in the homework. Time is going to be measured in seconds, which is sometimes just an S for seconds, or SEC. I do that abbreviation. And the speed, we're going to measure in feet per second, which is sometimes just written as FT for feet over S for second. The interesting thing up here in the formula is if you take feet per second and divide by seconds, then for your acceleration, your units are feet per second, which is sometimes written as feet per second squared. And the feet per second squared kind of makes sense because I'm dividing by seconds twice in a row, and seconds times seconds is squared seconds. But I know what a square foot is, but what the heck is a square second? It's kind of weird. On its own, it doesn't really mean anything, but feet divided by seconds twice is a change in speed, either an increase in acceleration or a decrease, a deceleration. So it turns out it is an important unit as a fraction because it tells us some speed has changed, gone up or down. And what we're going to try and do right now is we're going to try and solve the formula above for the v without the subscript. So we're going to see if we can get that guy all by itself. All right, so new page, let's give that a shot. So we have a is equal to the fraction with v minus v sub 0 in the top, t minus t sub 0 in the bottom. And we need to get this v right here on its own. Now, I can't get rid of the minus v in the top until I get rid of the denominator. And the denominator comes from a division, so the only way to get rid of the denominator here is to multiply by the whole denominator. So let's switch color. So I'm going to multiply by parentheses t minus t with a subscript 0 on it there. And just a reminder, I've talked about this before in other sessions for this class. When you have a big fraction bar and complicated stuff in the top, there's kind of an implied parentheses around the numerator and an implied parentheses around the denominator. And sometimes those parentheses matter to put them in, but often we just don't write them. We just assume it or ignore it. So again, if I take some quantity, my numerator, and I divide by a number, then I multiply the same by the same number, these two numbers are going to cancel each other out. So when I multiply by this number right here, again, a number divided by itself is 1. 1 times anything is itself. I'm going to get v minus v0 all by itself there. Now, the original equation didn't have that extra multiple there, so I've got to also multiply it on the other side to keep things balanced. So this factor of t minus t0 has to be multiplied on this side also to keep my equal sign correct. So I've got a couple of options. I can just leave that like that, or I could use the distributive property and distribute that through. So we have a couple ways to do this. I'm just going to leave it there for now. So one way to write the next line would be, on the right, it's simplified to v minus v0. On the left, it's just a times parentheses t minus t0. So I've almost got this v alone. The last step would be to just add this v sub 0 to the other side. So I could do that. Just add v sub 0 there, add v sub 0 there. I have a negative v sub 0 and a positive v sub 0. Those two together add to 0. 0 plus v is just v. So I got my v all alone on this side, and one version of the answer is what I have written on the other side. Parentheses t minus t0 times a plus v sub 0. I did it. I solved the equation. I have my v all by itself. Boom, done. If you really wanted to, you can distribute that a through, but it doesn't make life any better. So this would be my simplified version right there. That's just fine. Okay, so there's a homework problem like this where you're going to have to play with this equation. You're going to have to solve for a variable, kind of like I did here. You might solve for v, you might solve for t in the bottom. Other things we're going to do is plug in values to get answers. Now this is super important. The units of the numbers you're given matter for the acceleration to work out right. So if somebody gave me some information, like they gave me that the velocity, final velocity was, let's say, 30 miles per hour, I have a problem because all of these numbers in the formula are supposed to be feet per second or seconds, and miles per hour ain't feet per second. So I would need to convert if this came up. You need to pay attention to the units you're given. You might have to do a conversion. So an example of where I might apply this, I'm given a final velocity of 30 miles per hour. It could be my initial information is I started at a red light, which then turned green, and I drove for t equals 3 seconds later. I'm doing 30 miles per hour. And I want to find the acceleration in feet per second squared. So I have to do a conversion to make that happen here. So let's try that. So we're just going to plug into the given formula. A equals v minus v0 over t minus t0. And then my given information is I started at a stop. Right, so that would be at t0 is 0, and v0 is also 0, because I wasn't moving, no velocity. And then 3 seconds later, my velocity was 30 miles per hour. And this miles per hour is a problem because everything else is in feet per second. So I'm going to convert first. Miles per hour to feet per second. So to do that, we need to know a bit about miles, feet, seconds, and hours, which isn't too bad. There are 5,280 feet in a mile. You could look that up. And there's 60 seconds in a minute and 60 minutes an hour. So that 60 times 60 is going to give us 3,600 seconds in 1 hour. And so these are the values I need to make the conversion. So if I just start with my 30 miles, per literally means divide 1 hour. So that's the translation of miles per hour. To figure out whether I multiply or divide by these numbers, I set up conversion fractions. So then let's say I want to get rid of miles first, then mile would have to go in the bottom. I know how to get to feet, so feet goes in the top. The reason it goes in the bottom is so they can cancel when I multiply. And my conversion fraction says 1 mile is 5,280 feet. So this just reminds me, since that's on the top, I have to multiply. For the other one, to get rid of hours, since hours started in the bottom, hours has to go in the top to eliminate it. And then I can change to seconds. And 1 hour is 3,600 seconds. So the point of this fraction is because it's in the denominator, it tells me to divide. So to make this conversion, I'm just going to take 30 in my calculator times 5,280 divided by 3,600. And that is the answer in feet per second. So put that on a calculator just for fun, see if we can agree on what the result is. Let's see, 30 times 5,280 divided by 3,600. I think I typed that right. 5,280, 3,600, yep. I get 44 feet per second. So if I'm moving at 30 miles per hour, every second 44 feet goes by. And now I can plug all the given numbers into the formula to calculate the acceleration. So that was just warming up to use the formula. Finally, I can answer the question by plugging in the given numbers. That's supposed to be an A, it looks like a 9. And so I've got my V, instead of 30 miles per hour, is now 44 feet per second. Now this happened to come out to a whole number. These don't always come out to whole numbers. Sometimes things have decimals, keep that in mind. I was at a stop, so my initial velocity is 0 over 3 minus 0. So my acceleration is whatever 44 over 3 is. And let's see, 3 goes into 4 once with 1 left over. 3 goes into 14 4 times with 2 left over. So my calculator would say this is about 14.67 if I rounded to the nearest hundredth, and that would be in feet per second was the numerator, divided by seconds would be feet per second squared, is how it's often noted. And that's about, because I had to round. If I did that correctly, let's double check my calculator, divide by 3, yep. All right, so that's one of the harder homework problems. So I thought I'd give you a head start on that one. Let's switch